Welcome to this video on formulas in chemistry. We will provide a step-by-step guide with examples on how to determine the empirical and molecular formulas for high school chemistry. The empirical formula is the ratio of moles of the elements in a substance. It represents the lowest whole number ratio of a chemical formula. Remember that the chemical formula gives the actual ratio of elements. Let's compare empirical and molecular formulas. The empirical formula is the lowest whole number ratio of atoms in a compound. The molecular formula is the actual number of atoms of each element in a molecule. Examples are provided in the video. Now we will review the steps on how to find the empirical formula. To find the empirical formula, you will need the element symbol, atomic mass, mass or percentage of the element, the number of moles, the simplest atomic ratio, and the simplest whole number ratio. We can also determine the molecular formula by multiplying the empirical formula by n, where n is the molecular mass divided by the empirical formula mass. Let's work through an example. A stimulant is found to contain 49.48 grams of carbon, 5.19 grams of hydrogen, 28.85 grams of nitrogen, and 16.48 grams of oxygen. Its molar mass is 194.19 grams per mole. Following the steps, we find the moles and then divide by the smallest number of moles to get the ratio. The simplest whole number ratio is 4:5, 2:1 for carbon, hydrogen, nitrogen, and oxygen respectively. This gives us the empirical formula, C4H5N2O. To find the molecular formula, we calculate the empirical formula mass, which is 97.10 grams per mole. Then we divide the molar mass by the empirical formula mass to find n. In this case, n equals 2, resulting in the molecular formula C8H10 tetranitrogen dioxide. For our second example, we will calculate the empirical formula for a sample containing 40.0% carbon, 6.70% hydrogen, and 53.3% oxygen. We follow the same steps to find the relative number of atoms by dividing the percentage by the atomic mass. We then determine the simplest atomic ratio and the simplest whole number ratio, which leads us to the empirical formula CH2O. In example 3, we calculate the empirical formula from a sample containing 1.08 grams of aluminum and 0.96 grams of oxygen. First, we find the moles of each element. Next, we determine the mole ratio by dividing by the smallest mole value, which results in a 1:1.5 ratio. By multiplying by 2, we get the simplest whole number ratio of 2:3. The empirical formula is aluminium oxide. This slide summarizes the steps for calculating the empirical formula for aluminum oxide, starting with the mass, finding the moles, calculating the ratio, and determining the simplest whole number ratio to reach aluminium oxide. Example 4 asks us to find the molecular formula of a compound with an empirical formula of NO2, which has a molar mass of 92.0 grams per mole. The empirical formula mass of NO2 is 46.0 grams per mole. Dividing the molar mass by the empirical formula mass gives N equals 2. Multiplying the empirical formula by 2 yields the molecular formula N2O4.